This is Australia. You probably knew that already. But what you may not know is that, until recently, Australia held a unique title. It was the last major honey-producing country in the world that remained free of the Varroa mite, a tiny but devastating parasite and the greatest threat to honeybees globally. That is, until the summer of 2022. That's when everything changed. It began quietly. A single detection in New South Wales, near the port city of Newcastle. But in just a few short months, the situation spiraled. The government scrambled to contain the spread, and beekeepers were forced to make devastating sacrifices. Over 28,000 beehives were destroyed across 250 different apiaries as part of emergency eradication measures. To put that into perspective, the destruction zone covered more than 4 million acres, roughly 2% of the entire landmass of New South Wales. Each hive held anywhere between 10,000 and 30,000 bees. That's an average of about 560 million bees wiped out, not by the mite directly, but by humans trying to stop it. And here's the thing. Many of those hives weren't even infected. They were part of pollination operations, sent into farms to help fertilize crops. But once the mite was detected in the area, all hives, infected or not, were destroyed without exception. It was a scorched earth tactic meant to halt the pest in its tracks. But it also meant economic devastation for hundreds of beekeepers, many of whom lost their livelihoods overnight. So what exactly is this bee killer? And why is it so feared? Let's take a closer look. The culprit is the Varroa destructor mite. Tiny, reddish-brown, and no larger than a sesame seed. It may not look like much, but for honeybees, it's a death sentence. Originally native to Asia, the mite was relatively harmless to its original host, the Asian honeybee, Apis cerana. But everything changed when it made the leap to the European honeybee, Apis mellifera, the species used for most commercial honey production around the world. The European honeybee simply has no natural defenses against this parasite. While these mites are minuscule, they are proportionally among the largest parasitic mites on Earth. To understand just how invasive they are, imagine if a parasite the size of a dinner plate was feeding on you, crawling across your skin, biting, and consuming your organs. That's what bees are up against. And it gets worse. These mites don't just feed on adult bees. They specifically target bee brood, the developing larvae, and pupae. They infiltrate the cells where the young bees grow, latch on, and feed on their fat bodies, a crucial tissue responsible for immunity, detoxification, and overall health. This feeding causes deformities, weakens the bees, and spreads a suite of deadly viruses. The most notorious of these is the deformed wing virus. As the name suggests, bees infected with it often emerge from their cells with twisted, crumpled wings, misshapen bodies, and a greatly reduced lifespan. These bees can't fly, can't forage, and can't defend the hive. They die young, if they survive at all. As the infestation grows, the hive becomes weaker, with fewer healthy bees to collect nectar and pollen, or care for the queen and young. The colony slowly collapses. Entire hives vanish in a matter of weeks. Left unchecked, Varroa destructor is capable of wiping out wild and domesticated bee populations alike. For Australia, the arrival of the Varroa mite wasn't just a blow to beekeeping. It was a direct threat to food security. Honeybees are responsible for pollinating 1/3 of the food we eat. Apples, almonds, cherries, cucumbers, blueberries, the list goes on. Without pollination, crops don't bear fruit. And without bees, pollination doesn't happen. In Australia alone, honeybee pollination contributes roughly $4.2 billion annually to agricultural output. The honey industry itself brings in around $147 million a year. But if bees disappear, that number isn't just reduced, it drops to zero. Entire supply chains, from farmers to grocers to exporters, would be affected. Food prices would skyrocket. And there's no plan B. Nothing pollinates crops as efficiently or effectively as bees. But stopping the mite is incredibly difficult. Once introduced, it spreads like wildfire. When it was first detected in New South Wales in June 2022, authorities established a 31-mile biosecurity zone around the infected area. Beekeepers were required to report the locations of their hives. Those within a 6-mile core were destroyed. The surrounding ring was monitored heavily for signs of infestation. Yet despite these efforts, the mite continued to spread. Human activity played a major role. Commercial beekeeping often involves moving hives across vast distances for seasonal pollination. One of the biggest events is the annual almond pollination, when over 300,000 hives are relocated to Victoria's almond farms between July and August. In 2022, Companies like Dukan Bees moved thousands of hives from areas, including Kempsey, a town that later turned out to be a hotspot for mite infection. By the time the threat was understood, it was too late. Many infected hives had already returned home or continued to other locations, carrying the mites with them. The result? Rapid spread across New South Wales, including outbreaks in Coffs Harbour and regions bordering Victoria. But mites don't fly. So how do they move? When an infected hive weakens or collapses, nearby bees often rob it for honey. And when they do, the mites seize the opportunity, hitching rides back to new colonies. Even modern beekeeping practices, like placing hives close together, create the perfect storm for infestation. Eventually, authorities had to face the facts. Eradication was no longer realistic. Despite spending over $100 million on the effort, containment failed. In 2023, the Australian government officially pivoted from eradication to management. Beekeepers were advised to adapt to the presence of the mite and prepare for long-term coexistence. For many, this was devastating news, especially when considering that all the previously destroyed hives, perhaps hundreds of millions of bees, may have died in vain. Still, it's not all doom and gloom. There's hope in science and in nature. Some honeybees have evolved resistance to the Varroa mite. These bees practice what scientists call Varroa-sensitive hygiene. They detect mites in the brood cells and remove the infected larvae before the mites can reproduce. Others groom each other and chew off the mite's legs. These traits are genetic and could be the key to survival. The challenge: most commercial bee colonies don't have these behaviors, and even if they do, they're often less productive in terms of honey output. As a result, beekeepers have historically bred for yield over resilience. But that might have to change. Researchers are now developing artificial insemination techniques and selective breeding programs to encourage mite-resistant traits in bee populations. It's not an overnight solution, but it's a long-term path to coexistence. There's also a surprising twist to this story: native bees. Australia is home to more than 2,000 species of native bees. These insects are incredibly diverse. Some are stingless, others solitary, some tiny, some metallic in color. And they've existed on the continent for millions of years without any need for imported European honeybees. Now, with the spotlight on pollinators, native bees might finally get the recognition and protection they deserve. Ironically, the mite's invasion could offer native species a second chance. With the decline of honeybees, native bees may become more important to both agriculture and ecosystems. In time, they could fill some of the pollination roles left vacant by declining honeybee colonies. So where does this leave us? The arrival of the Varroa mite in Australia marks the end of an era and the beginning of a new one. Beekeepers, scientists, and farmers are all adapting to a changed landscape. The goal now is not elimination, but adaptation, to find a way forward that protects bees, secures food production, and preserves the fragile ecosystems that depend on pollination. Because in the end, this isn't just a story about bees. It's a story about us, and whether we can respond to threats not just with force, but with understanding, cooperation, and innovation. China's agricultural land is shrinking, and fast. That may come as a surprise for a country that's been turning deserts green, tree by tree, acre by acre. But while environmental restoration is a long game, degradation moves quickly. Between industrial development, booming cities, and widespread pollution, China is losing valuable farmland every year. By the end of 2019, China's total arable land measured just under 494,000 square miles. That's a big number on paper, but it's a 6% drop from just a decade earlier, in 2009. The causes are clear: relentless urban expansion, growing industrial demands, inefficient farming practices, and serious environmental degradation. But China's response to this agricultural crisis includes a rather unexpected ally: the crayfish. Yes, crayfish, those small freshwater crustaceans with snapping claws. It sounds strange, even absurd, but these little creatures are playing an outsized role in not just revitalizing farmland, but also in fighting poverty and transforming rural economies. Their journey from exotic novelty to agricultural powerhouse is one of the most fascinating stories in modern farming. The species making waves in China is Procambarus clarkii, commonly known as the red swamp crayfish. It's native to the southern United States, not East Asia. In fact, for most of China's history, crayfish weren't even part of the local ecosystem or cuisine. So how did they get there? The introduction of crayfish dates back to the Second Sino-Japanese War between 1937 and 1945. At the time, Crayfish were kept as pets by some Japanese, and many were brought along during the occupation of parts of China. From there, they slowly made their way into China's rivers, lakes, and rice paddies, spreading quietly, unnoticed by most. For decades, they remained relatively obscure. But by the early 1990s, the story started to change. A culinary trend began to take hold. Crayfish dishes, often spicy, stewed, or soaked in wine, gained popularity in restaurants and street stalls across China. The public couldn't get enough. It was a culinary explosion that no one saw coming. Today, China consumes over 90% of the world's crayfish supply. That's more than 1 million tons of crayfish devoured each year. With such massive demand, it was only a matter of time before farming operations ramped up. From small family-run ponds to massive industrial-scale farms, crayfish cultivation has become a national phenomenon. According to China's Ministry of Agriculture and Rural Affairs, crayfish farming was already significant back in 2007, with an annual output of 265,000 tons. Less than a decade later, in 2016, that number had more than tripled to 850,000 tons. Wild-caught crayfish added another 49,000 tons to the total. But the real boom was yet to come. By 2022, China's crayfish production reached a staggering 2.5 million tons. The entire industry was valued at over 369 billion yuan, or about 53 billion US dollars. That's more than the GDP of some small countries. Crayfish were no longer just a culinary trend. They had become a cornerstone of the rural economy. One standout example is Shui County, located in eastern China's Jiangsu province. Known as the crayfish capital of China, Shui has transformed its economy around these crustaceans. By 2025, the county had established 165,000 acres of eco-friendly crayfish farming zones. Over 210,000 residents, more than the population of Salt Lake City, work in crayfish-related industries. Even the crayfish themselves have evolved. Through selective breeding, local farmers developed a line of crayfish that grow larger and reach maturity faster than the original imports. This faster-growing strain can earn farmers an additional 500 yuan per mu, a Chinese land measurement equal to about 1/6 of an acre. It's a significant economic boost in rural areas, where incomes are often limited. In Hubei province, another crayfish stronghold, the city of Xinjiang proudly boasts a 49-foot-tall crayfish statue, the tallest in the world, officially listed in the Guinness Book of Records. The city has become a tourist destination, often called the eco-city of crayfish, with restaurants, educational tours, and scenic farming zones all built around the industry. At one processing plant alone in Xinjiang, 500 workers handle 80 tons of crayfish in just a 10-hour shift. Multiply that by the hundreds of facilities scattered across China, and it becomes clear. This is not just a food item, it's a national enterprise. But perhaps the most fascinating development of all is how crayfish are being integrated directly into agriculture, specifically into rice farming. This method is known as integrated crayfish rice farming, and it's proving to be one of China's most promising sustainable farming innovations. The idea is simple yet ingenious. Farmers plant rice in their paddies as usual, but they also dig circular trenches around the fields. These serve as habitats for crayfish. After the rice is harvested, the leftover straw is left in the field, and the paddies are flooded, creating an ideal nursery for young crayfish. The straw provides warmth and shelter during cooler months and eventually decomposes, becoming food for the crayfish. As omnivorous scavengers, crayfish feed on detritus, decomposing plant material, and small aquatic organisms. Their constant foraging keeps the paddies clean and reduces pests. Meanwhile, crayfish waste acts as a natural fertilizer, releasing organic carbon, nitrogen, and potassium, essential nutrients for rice growth. And there's more. When crayfish die, their bodies decompose and further enrich the soil. This cycle significantly reduces the need for chemical fertilizers and pesticides, resulting in cleaner, healthier rice and less environmental pollution. A study published in the Chinese Journal of Ecological Agriculture monitored integrated crayfish rice systems from 2005 to 2015. The results showed that these systems significantly outperformed traditional monoculture rice fields in terms of soil health, biodiversity, and yield. Before 2014, farmers would rotate between crayfish and rice on the same fields, but the introduction of mixed farming changed everything. By 2015, 93% of local farms in participating regions had adopted this integrated approach. According to a 2018 report by the Ministry of Agriculture, crayfish production in one city doubled in a single year, reaching 70,000 tons in 2017. This method is now widely seen as a way to maximize yields, increase rural incomes, and make use of less fertile soil, all without compromising environmental sustainability. As revolutionary as this farming method is, it's not without its downsides. First, growing rice and crayfish together isn't as easy as it might seem. It requires technical knowledge, careful planning, and precise water management. Crayfish are resilient, but they're also opportunistic feeders. If managed poorly, they can start damaging the rice crop they're meant to support. Then there's the issue of land use. To create permanent crayfish habitats, many farmers dig deep trenches and flood fields year-round. This shift from seasonal to permanent flooding reduces the availability of dry land, especially for winter crops like wheat, barley, and rye. That's a serious concern. While rice remains China's primary grain, with 207.5 million tons produced in 2024, wheat is close behind at 140.1 million tons. Wheat is essential for bread, noodles, dumplings, and other staples. Reducing wheat output could strain China's food security, especially as demand continues to rise. One striking example comes from the Yangtze River Basin, where over 1.6 million acres of rice and crayfish fields used to support winter wheat cultivation. Now, much of that land stays underwater year-round, making it unsuitable for wheat farming. And that's just one region. This growing tension between aquaculture and dry farming raises important questions. Can China strike a balance between maximizing income from crayfish and protecting long-term grain supplies? Can integrated systems evolve to support both summer and winter crops? Despite the challenges, China's crayfish experiment has captured the attention of the world. It's a rare example of an invasive species being transformed into a tool for sustainable farming, poverty alleviation, and even national pride. From obscure foreign invader to economic driver, crayfish have changed the face of rural China. They've turned remote counties into thriving communities, reduced reliance on chemical fertilizers, and offered a viable path for regenerating degraded land.